Let's suppose that by now I'm pretty confident about the model being okay. I'd like to go check the assumptions, where the first one, at least the first serious one, would be whether or not there is heteroscedasticity. And for that, we had the eyeball the plot method. Not great, but let's do it anyhow. Here we have our original regression, and well, perhaps it's easier to go through the menu here. So regression, linear. Same model again. Now I want the plots. This one. There, and there. Let's see what that does. First, in terms of syntax, this will give me these two extra commands. I'm also saving the prediction here. And, well, let's see, let's get rid of this and that as well. And let's also predict the residuals. That might be of use. Analyze, regression, linear, and I'll leave it all the same, but I want to save not only the predicted values, but also the residuals. And then the command looks like this, almost the same, but I now have also this behind it. Okay, let's see what happens. I'm interested in heteroscedasticity, so I look at the plots. Here we have it. This should be random noise. Well, it's pretty much the same as we had before, only these are worrying in some sense. Here, this line looks okay. Here, also okay. Also okay there, just a line with some noise around it, and this one is okay as well. So it's like we had in the beginning. The only ones that might worry me are these and those two, but in itself I do not mind so much about this. So with plots like this, I would be pretty confident to just let it go and conclude that there is no heteroscedasticity here based on just the plots. If we want, we can do it better in the sense that we can actually test it. There is a slide in the set of slides from one of the lectures that shows you how it is done. And this is how it goes. So just do it so that you know how it would work if you really need it. But it's a bit of work and only can be done reasonably if we have just a handful of variables like here. Because what you need is the following. You need the residual and then square it. So I compute the residual and then square, what shall I call that? Let's say residual squared equal to, let's peek in my data. It's called res underscore 1 underscore 1 times res underscore 1. And the rest I actually prepared. So I can just paste it in there. Have it here, this line. Here I continue. I create vintage squared, winter rain squared, degrees rain squared, harvest rain squared, and all the cross products that there are. Vintage times winter rain, vintage times degrees, vintage times harvest rain, winter rain times degrees, winter rain times harvest rain, degrees times harvest rain. Up, that's it. We have a long list, we execute it, and then we run a regression with as our dependent variable that residual squared and the whole list of variables that we have. Okay, that's just the recipe as you could get it from the slide. Let's see what happens if we simply run it. Okay, here we go. We get an analysis of variance table. If we peek at what the coefficient table looks like, this is really dreadful, as you can imagine. All the variance and inflation factors are through the roof, but luckily none of that matters here. The only thing that we need to know here is the r squared, which is 0.421, and n, the number of cases. And the number of cases that we have included here is 27. And what we need to do is multiply these two. So we have 27 times 0.421, that's 11.367. Okay, let's keep that in mind. And that number we need, because if we would be able to calculate, and that I prepared as well, a chi-square distribution as you see it here, with that number 11.367 and 10 degrees of freedom, where the 10 is taken from the fact that we've used 10 variables. And this value is the actual test. If it would have been smaller than 0.05, that would be proof of heteroscedasticity. That's not good. Here it's larger than 0.05, so there is no proof of heteroscedasticity. So indeed, we're good to go. The actual test is not showing any heteroscedasticity. As I said, this is not easy to do if you have lots of variables. Even 10 variables would give you 10 squared ones and a lot of cross products of all these different variables. So it's doable, but not very convenient. But still, I wanted to show that in principle it is possible to also test officially whether or not the thing is heteroscedastic.